Okay, well, Happy New Year. I decided to look for a property of 2021, which was quite arbitrary, and see if I could make up a definition. I'm going to define power path numbers, try to make up a couple of questions about power path numbers, and then my excuse for talking about this is just the fact that 2021 is a power path number. So for the definition, we start with a sequence of distinct integers. So there's your sequence of distinct integers. And the first one gets raised to the power of the second one, and then the second one gets raised to the power of the third one, and so on. And then you add up those quantities. So for an example, if we have the sequence 3, 4, 1, 7, the power path sum for that sequence would be 3 to the 4 plus 4 to the 1 plus 1 to the 7. And so that's 86. So that means 86 is going to be called a power path number. Right? So a power path number is, by definition, the power path sum for a sequence of distinct positive integers. And the reason I'm going for distinct here is because if the numbers in the sequence were all allowed to be the same, I could just have a bunch of ones consecutively, like this. And then I could arrange for any number to be a power path number. So I'm trying to forbid this situation. One way to forbid it is just to not allow the numbers in the sequence to be the same. There's other ways you could define it if you like, but I've chosen this one for now. So 86 is a power path number. 2021 is also a power path number. If you want to look for the representation to see how hard or easy it is to find a representation, you can pause the video now and look for it for a few minutes. Okay, so here's a couple of questions. First of all, if you're given a power path number is the sequence determined, well, we already know the answer is no. For example, we've already looked at a sequence which proves that 86 is a power path number, 3 to the 4, 4 to the 1, plus 1 to the 7, and so on. But of course, 1 to the 7 is the same as 1 to the 6, and 1 to the 6 is the same as 1 to the 13, for example. So when we talk about the sequence being determined, if we have two sequences where the second last number is a 1, then we would somehow view any two such sequences as equivalent, because otherwise the sequence isn't determined for some trivial reason. So we would have to make a careful definition to take that into account. But other than that kind of trivial situation, is 86 uniquely represented as a power path number? I don't know. So maybe there's a smallest number that has two different representations with two different sequences. Right? So that's one possible question. Another question we could ask is what proportion of positive integers are power path numbers? And so the way we'd have to ask this is we'd have to say let pi of n be the number of power path numbers less than or equal to n, and then we'd have to take the limit as n goes to infinity or something like that, right? In the typical way. So we'd have to find some version of this question. Other variations of this question involve not necessarily requiring the integers in the sequence to be positive. So what if we allow negative integers for the sequence? That would probably change which numbers are power path numbers. There's other ways to just make the question interesting rather than just insisting that all of the numbers in the sequence are distinct. Maybe we just don't allow the number 1 or something like that. Maybe there's other variations that are more interesting, so I haven't used this variation. This variation seems more interesting, allowing negative numbers, but I'll leave that up to whoever's going to think about this. And so now finally here's the example. Here's an example that shows that 2021 is a power path number. So there it is. You know, other variations you could think of, power cyclic numbers maybe, right? So instead of having a sequence of numbers and stopping when you get to the end, maybe you roll over, right? So if I was to look at that and use the same sequence, this would show that 10 to the power of 9 plus 2021 would be a power cyclic number, right? So with that definition, I don't know if 2021 is a power cyclic number because this is a billion off of that, but anyway, close enough. And so all kinds of questions, right? Are most integers power path numbers, right? Using distinct positive integers for sequences. Is there a way to tell? All sorts of interesting questions.